Hello and welcome back to Chopstick Maths. In this video, we shall solve a problem from the chapter of exact differential equation, exercise 1, sum number 3. The given differential equation is dy by dx is equal to y plus 1 upon y plus 2 into e raised to y minus x. So let us rewrite this in the form m dx plus n dy is equal to 0. So first let us cross multiply. This would be y plus 2 e raised to y minus x dy equals to y plus 1 dx. Let's rearrange this and we will get y plus 1 dx minus y plus 2 e raised to y minus x dy is equal to 0. Now let us take the negative sign inside so that we can write it in the form m dx plus n dy is equal to 0. So when we take the sign inside, every term will change its sign. So this would be plus into bracket minus y plus 2 e raised to y. The minus x would become plus x dy is equal to 0. Now the equation is in the form m dx plus n dy is equal to 0, where m is y plus 1 and n is minus y plus 2 e raised to y plus x. So now let us first prove that this equation is an exact differential equation. So m is y plus 1 and let us differentiate this m partially with respect to y. So del m by del y is equal to del by del y of y plus del by del y of 1. So the derivative of y is 1 and 1 being a constant, its derivative is 0. So del m by del y is equal to 1. Now n equals to minus y plus 2 e raised to y plus x. So let us open up this bracket so we can differentiate it very easily. So this would be minus e raised to y into y, that would be minus y e raised to y minus 2 e raised to y plus x, that is equal to n. And now let us partially differentiate n with respect to x. So del n by del x is minus del by del x of y into e raised to y minus 2 del by del x of e raised to y plus del by del x of x. Now whenever we are partially differentiating with respect to x, we treat y as a constant. So derivative of y into e raised to y is 0, derivative of e raised to y is 0 and derivative of x is 1. So this would be minus 0 minus 2 into 0, which is 0 plus 1. So del n by del x is equal to 1. So from 1 and 2, we can see that del m by del y is equal to 1, del n by del x is equal to 1. So del m by del y is equal to del n by del x. So we can say that the given differential equation is exact. Now let us find the solution to this exact differential equation. The given equation is y plus 1 dx plus minus y plus 2 e raised to y plus x dy is equal to 0. Let us open up this bracket inside so it becomes easy for us to integrate it. So y plus 1 dx plus minus y e raised to y minus 2 e raised to y plus x dy is equal to 0. Now the solution of this differential equation is integral of m dx treating y as a constant plus integral of n dy and only integrating those terms which are free of x is equal to c, where c is some constant. So here this will be y is a constant because when you are integrating m dx, you have to treat y as a constant. So it will be outside the integral sign. So y integral dx plus 1, that would be integral dx. Now when you are integrating n, you should only integrate those terms which are free of x. So The first term minus y e raised to y is free of x. So we integrate this plus integral minus y e raised to y dy. The second term minus 2 e raised to y is also free of x. So we integrate this term minus 2 integral e raised to y dy. And the last term is a term x. So we neglect that term as we do not integrate the terms that contain x. So this will be equal to c, which is a constant. So rewriting this, y integral dy plus integral dx minus y e raised to y dy minus 2 integral dy is equal to c. Now this is y integral dx plus integral dx minus integral y e raised to y dy minus 2 integral e raised to y dy is equal to c. Now if you see, these three terms can be very easily integrated, but this integral of y e raised to y, we will have to apply a product rule. And the formula for this product rule is integral of u into v dx is uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4. Now this dash represents the derivative, first derivative, second derivative, third derivative, and this suffix 1, v1, v2, v3 represents the integration. Now we can use this particular formula only when the u is of the type y raised to n, where n is a positive integer and v is integrable. Now let us check, our u is y, that is y raised to 1. So y raised to n, that is our u is y raised to 1, is a positive integer, and our v is e raised to y, and e raised to y can be integrated easily. Integral of e raised to y is e raised to y. So we can apply this particular uv rule. So integrating integral of y e raised to y dy is u, that is y, v1 is the integral of e raised to y, that is e raised to y, minus taking the derivative of u, that is the derivative of y is 1, again integrating e raised to y, that is e raised to y again, plus the second derivative, taking the derivative of 1, which is 0, and again integrating e raised to y, that is e raised to y. But now 0 into e raised to y gives us 0, so here we stop proceeding further. So integral of y e raised to y is y e raised to y minus e raised to y, and let us call this 3. So this is 2 and this is our equation 3. Now let us substitute this 3, that is integral y e raised to y, in 2, and we will get y integral dx is y into x plus integral of dx is x minus integral of y into e raised to y we have already calculated, which is y e raised to y minus e raised to y. So this is minus y e raised to y minus e raised to y minus 2 integral of e raised to y is e raised to y. So it is minus 2 e raised to y is equal to c dash. So now let us open the bracket. Yx plus x minus y e raised to y plus e raised to y minus 2 e raised to y is equal to c dash. So xy plus x minus e raised to y and plus e raised to y minus 2 e raised to y gives us minus e raised to y is equal to c dash. We can take a common factor x, that is x into y plus 1, and here we can take the common factor minus e raised to y into y plus 1 is equal to c dash. Further we can take the term y plus 1 common, so it would be y plus 1 into x minus e raised to y is equal to c dash. And now we can rewrite this as, because there is a property of subtraction a minus b is equal to minus b minus a. So we can reverse these terms. E raised to y minus x with the minus outside. So it is minus y plus 1 e raised to y minus x is equal to c dash. Now we multiply with minus 1 on both sides. So it is y plus 1 e raised to y minus x is minus c dash. And now we can write this minus c dash is equal to another constant c. So minus c dash is equal to c. So y plus 1 into e raised to y minus x is equal to c. This is the required solution of the given differential equation. Thank you very much for watching the video.